In this video we will discuss about different types of design of this protein degrader. So far we have understood the pharmacodynamics and pharmacokinetics of these protein degraders using two different maps, that is heat map and the spider map. Here we will discuss what are the different designs that are available to design these protein degraders. First one of them is nanoparticle based, in which case a targeting ligand is attached to the nanoparticles. Nanoparticles contains the degraders. So once this targeting ligand attached to the protein of interest, then thereafter the proximity of the protein of interest and the degraders will be very minimum, and the efficiencies of this degrader to target the protein of interest will be high. Uh, so this is one of the approach. In another approach where they used antibodies with direct attachment to those degraders. In this case, the ratio of uh, degraders to antibodies varies depending on the efficacies of the degraders, the antibodies, and number of sites it is going to attach to the antibodies. So it works on the similar way that works for the panel A, that is antibody attached to the protein of interest, and that degraders will be in close proximity to the protein of interest. Will connect upon it. And in terms of their half-life time period or their circulation time, we can see the circulation times of this antibody, which is directly attached to the protein degraders, is high compared to the case where nanoparticle attached to the targeting ligand is used. And if only direct degraders is used, then its half-life is further reduced, because it will be easier for the immune system of the patient to detect this as a foreign object and act against it. And there's another type of approach that is used for the protein degraders is subcutaneous injections. Here a long injection is directly used to inject the protein degraders at the site, near the site. So in this case a depot is formed and the degraders is contains in the depot, and this degrader will be released. In this case there is no control over the rate at which this degrader is released, whereas in the case of controlled release, the degraders are released at a slower rate. Thereby they helps in maintaining the high half-life time period within the patient's body compared to the first case. And these things is evident in the panel E, where we can see that the controlled release will cause a high dose even after like 14 days, whereas in the case of this alone protein degraders, half-life period is very low, and they have not shown the time period for this degraders releasing from depot at a uncontrolled rate. So because most of the times people are used these release degraders with a control rate. So these are some of the different kinds of designs, or two major kind of designs, and within those two major kind of design there is like two different categories that can be used. And so far uh, some of the previous data shows that the efficiencies of these antibodies that are directly targeting to the antibodies that are directly attaching to the degraders seems to have a better functions because of the less foreign particles that it contains, whereas in the case of these nanoparticles, this whole nanoparticles is a foreign objects, so there is a high chance of immune response in the panel A compared to the panel B. And in this case also, this since the antibody directly attached to the protein of interest, even if it goes to the recycling process through endocytosis, this antibodies with degraders has a high chance to get recycled out of the cells instead of being targeted to the lysosomes, or for lysosomes, or the autolysosomes for the degradations. So the in the previous video we have understood the pharmacodynamics and pharmacokinetics, and from that this panel C and panel E are derived, and we can see that the control release and the antibodies with directly attached to the degraders seems to perform better compared to the other alternatives. So I hope you understood some basic understandings about this protein degrader design. And if you need to understand more about this topic, that is protein degrader designs in detail, you can go through the reference that has been provided in the description. That's all for this video. Thank you for your time.